Hello again. In this video, we're going to begin talking about the material from Chapter 4, where we start using the derivative to solve problems in calculus. So the first situation we're going to look at is a case where we have a function defined on an interval, and what we're going to do is we're going to try to find the absolute maximum y value and the absolute minimum y value that the function takes on that interval. And those are known as the absolute maximum and the absolute minimum. In fact, let's formally define those mathematically. So let's talk about the absolute maximum first. The formal definition of absolute maximum is this. It says, let f be defined on an interval I containing c. If f of c is greater than or equal to f of x for every x in the interval, then f has an absolute maximum value of f of c on the interval I, and it happens to occur at the point x is equal to c. Now, if f of c is less than or equal to f of x for every x in the interval I, then f has an absolute minimum value of f of c on the interval I, and it occurs at x equals c. So those are the formal definitions of absolute maximum and absolute minimum. Okay, so let's look at an example. Let's say we have this function f of x is equal to x squared, which happens to be this parabola that opens upward, and it has a vertex at the origin. Okay, and let's try to find the absolute maximum y value that this function takes on the interval from negative infinity to infinity. Well, if you look at the graph, I think you can see that since this function continues to increase on both sides, that it doesn't have an absolute maximum, because these are both heading towards infinity. Okay, but it does have an absolute minimum. The absolute minimum is 0, and that's because the smallest y value that this function takes on is 0. You can't go below 0 on the y-axis. Now, where does that occur? Well, the absolute minimum happens to occur when x is 0. Okay, so let's change the interval. Let's say we have the same function, f of x is equal to x squared. Let's try to find the absolute maximum and minimum on the interval, the closed interval from 0 to 2. Okay, so the function would look like this in that case. But look, you can see that the absolute maximum is actually 4. That's the largest y value that this function takes on this interval from 0 to 2. Okay, so the absolute maximum is now 4, and it occurs when x is equal to 2. Now, the absolute minimum is still 0, and it occurs when x is equal to 0, just like it did before. So, absolute maximums and absolute minimums depend on the function, but they also depend on the interval that you're looking at the function on. Okay, this leads us to the extreme value theorem, theorem 4.1, which says this. A function that's continuous on a closed interval has an absolute maximum value and an absolute minimum value on that interval. So this is known as an existence theorem. What it does is it guarantees us the existence of both an absolute maximum and an absolute minimum on the interval. And there's only two conditions that we need to satisfy in order to guarantee the existence of both of those on the interval. So what do we need? We need the function to be continuous on a closed interval. Those are the two conditions that you need to guarantee the existence of both an absolute max and an absolute min on the interval. Okay, so let me show you why you need both conditions. Well, first of all, here's a case where we have a closed interval, right, from 0 to 2. That's a closed interval. And the function's continuous on that closed interval. And you can see that, in this case, we had both, right? We had an absolute maximum and an absolute minimum, right? The maximum was 4, the minimum was 0. Let's say it's not a closed interval. Let's say we have a half-open interval. Okay, this side doesn't include 0. This one includes 2, but this doesn't include 0. So if you don't include the 0, then this point right here doesn't exist on the function, right? 0, 0 is no longer a point on the function. So in that case, there is no absolute minimum because the y value here continues to get closer to 0, but it never reaches it. And so you can't declare there to be a minimum here. Like if you said the minimum was 0.1, I would say no, I can go below 0.1 and get to 0.01. And you can't declare 0 to be the minimum because 0 is no longer on this function. 0.00 is no longer part of this function. Now, it does have an absolute maximum, okay, but we're not guaranteed to have both, and you can see that. We don't have an absolute minimum. Why? Because, this function's continuous, but it's continuous on a half-open interval. It's not continuous on a closed interval, like it was in this case. Okay? You could also have the case where it's continuous on an open interval, right, where both of these are not included, the 0 and the 2 are not included in the interval. And in that case, you don't have either. You don't have an absolute max or an absolute min. So you're failing, you have continuity, but you're not having continuity on a closed interval. That's the issue. Now, there's also the possibility that you have a closed interval. Let's look at this example here. This is a closed interval from A to B because it includes both of these endpoints, right? These are shaded in. So this is a closed interval, right, from A to B. But notice the function's not continuous on that closed interval. There's a discontinuity at this particular point here. And so we're not satisfying the two conditions of the extreme value theorem. We lack continuity on the closed interval. We do have a closed interval, we just don't have continuity on the closed interval. And I think you can see the problem. You do not have an absolute maximum y value here because this function continues to creep up towards this y value. It will never reach it. So let's suppose this was equal to 7, right? The y value was 7. You can get to 6.9, you can get to 6.99, you can get to 6.999. So you can always continue to get closer to 7, but you'll never reach 7. And so for that reason, you can't declare there to be a maximum. You can always add another 9 on, right? You could say 6.999999, 99999, right? So it doesn't have an absolute maximum. And so it's not guaranteed to have both because it does not have continuity on a closed interval. Okay, so just remember the extreme value theorem. As long as you have continuity on a closed interval, then you're guaranteed to have both. If you don't satisfy those two conditions, then who knows, right? You might have both, you might have one, or you might not have either. Okay? All right, I hope you found this video helpful. Thank you for watching. Bye-bye.